If you're writing Rust code, you'll use Cargo every single day. It's not just a build system, it's your project manager, dependency handler, and even a testing tool, all wrapped in one. By the end of this video, you'll understand how Cargo helps you organize Rust projects, manage dependencies, and configure your application efficiently. So let's dive right in. When you install Rust using RustUp, you automatically get Cargo installed along with it. Cargo is the tool that helps you build and run Rust projects without manually managing the compiler or linking files. Let's start with the most basic thing, creating a new project. I'll open my terminal and type this command. Now look what happens. Cargo creates a new directory called Introduction to Cargo, and inside it, we have a cargo.toml file and a src directory with a main.rs file. So, here's what we've got. Cargo.toml is the configuration file. It's where we define the project's metadata and its dependencies. It's kind of like the package.json file in Node.js or pyproject.toml in Python. Let's take a look. This package section tells Cargo what our project is called, what version it is, and which edition of Rust we're using. The dependencies section is where we'll list all the external crates, or libraries, we want to use in our project. Now let's open main.rs. Nice and simple. To build this project, we just type cargo build. Cargo will compile the project and create an executable in the target debug directory. And if we want to run it directly, we can just type cargo run. This combines building and running in one step. Terminal output will look like this. Compiling Introduction to Cargo. Hello, Cargo. Perfect. Now, sometimes we want to make sure everything compiles, but don't actually want to run it yet. In that case, we can use this command, cargo check. This command checks for compilation errors without producing an executable, and it's super fast. It's something you'll use all the time during development to make sure your code is in good shape. Now let's talk about dependencies, one of Cargo's superpowers. Imagine you're building a web scraper, and you want to fetch data from websites. You could write all that HTTP logic yourself, but that's reinventing the wheel. Instead, you can use a crate-like request. Let's add it to our project. Open cargo.toml and add this line under dependencies. Then, in main.rs, we can write this code. Now, when we run cargo run, Cargo will automatically download request and all its dependencies from crates.io. You don't have to worry about downloading or linking anything manually. Cargo does all that for you. Let's make another example. Say we want to parse some JSON data from a file. We can add a crate like serd for serialization and deserialization. In cargo.toml, add these lines. Then in main.rs, we can use it like this. Now Cargo handles everything. Downloading crates, checking versions, building them, and linking them properly. This is where Cargo shines. It manages the ecosystem for you. Now, sometimes we want to work with multiple projects in one workspace. For example, a web server and a command line tool that share some logic. Cargo supports that using workspaces. Let's create one. In the terminal, I'll run these commands to create member crates. Inside the workspace root directory, create separate directories for each of your projects, or crates. Each of these directories will contain its own cargo.toml file and source code. Now, in the root directory, we'll create a cargo.toml like this to set up a Cargo workspace. We will add a workspace section that will allow us to add members to the workspace. This root cargo.toml file will not contain a package section, as it represents a virtual workspace that only manages its members. This way, both server and client are treated as part of a single workspace. If we run cargo build at the root, Cargo will build both projects together efficiently, sharing dependencies and build cache. This is perfect for larger systems, like a distributed backend or microservices architecture. If one crate in your workspace depends on another, you can specify this dependency in the dependent crates cargo.toml using a path dependency. For example, in client cargo.toml, we can add dependency of server like this. Now let's look at release builds. By default, Cargo compiles in debug mode, which is fast but not optimized. When you're ready to ship your code, use this command, cargo build release. This compiles your code with optimizations turned on and places the binary in target, release. A debug build runs quickly, but is slower to execute. A release build takes a little longer to compile but runs much faster, which is critical for performance-sensitive applications like servers or games. Now, here's something super cool. You can also define scripts and metadata inside your Cargo manifest. For example, if you want to include author info or specify a license, you can add it like this. And you can even define build scripts using build.rs, which lets you run custom logic before your project compiles. For example, maybe you want to generate code dynamically or embed version info in the binary. Cargo gives you full flexibility for that. Consider a scenario where you want to generate a Rust module containing a message based on some dynamic input. First, create build.rs file in the root of your crate and write this code. Now in main.rs or any other Rust file in your crate, we can use it like this. The build.rs script uses env, var os out directory, to find the directory where Cargo stores build artifacts. It then creates a file named generatedMessage.rs within this directory and writes a simple Rust function into it. This print macro is a special instruction to Cargo, indicating that if build.rs is modified, the build script should be rerun. In main.rs, this include macro dynamically includes the generated file at compile time, making its contents available to your main program. When you run Cargo build, Cargo will first execute build.rs, generating generatedMessage.rs, and then compile your main crate, including the newly generated code. Let's look at the real-world use case. Imagine you're building a small Rust API service. You might have dependencies like Tokio, Oxum, and Surd. With these 3 crates, you can create an async web API in just a few lines of code, and Cargo will manage it all. In main.rs, we are using the Oxum Web Framework to create a simple web server that listens on localhost 3000 and responds with hello from Oxum when you access the root path. When we run Cargo run, Cargo compiles all dependencies, runs the code, and we instantly have a web server. That's the magic of Cargo, from zero to production-ready app with minimal setup. So, to summarize, Cargo handles project creation, compilation, dependency management, testing, and even deployment workflows. It's your all-in-one Swiss Army knife for Rust development.